Hey guys, welcome back to Data with Dominic, and today's video is an exciting one. We're going to be taking you through the basics of the Kusto query language, and we're going to be actually getting our hands dirty today. So this video is right for you if you're an absolute novice or a very or in the very early stages of learning KQL. So we're going to take you through the most common and widely used KQL operators, and at the end of this video, you'll have a good understanding or a good overall picture of how the KQL language works. So definitely watch us until the end. Watch this video until the end, and you should be pretty well informed of the KQL language. Before we begin, I just want to ask you guys, thank you so much for all the support you've been showing us. But please do continue to like, subscribe, and share and comment on these videos, as it helps us to continue this channel. So definitely, please do remember to subscribe if you want to. So let's dive right into the video, right? So coming to the KQL language, uh, the environment that we're going to be using today to use it is the Azure Data Explorer. I'll link to the last two videos in this playlist, where in the first one I show you how to set up this free environment for yourself so you can work with KQL, and in the second one I show you how to ingest some sample data into the Azure Data Explorer so that we can work with KQL. So in the last video we inserted the storm events table. So that's what we're going to be working with today, and that's what I'm going to be using to show you most of the common operators in the KQL language. So to begin, we know that KQL stores data similar to SQL. That is, it has tables and databases, and it follows a sort of schema-based structure. So as you can see, we have this database called demo database, and in that database we have these two tables. So now suppose I wanted to see what all tables I had in a particular database. I can do a dot show tables. All right, and once I hit this run, it refers to the current cluster slash database that we're in, and it pulls all the particular tables that are available in it. So we've got two tables, and you can see those two tables have been listed here. So test, and we've got storm events. All right, so that's just a basic admin function. Good to know. Now coming to KQL itself, suppose what is the most basic query that you can think of in SQL, right? It's probably the select star from a particular table, right, which just queries the whole table and lists out all the data from all the columns in that particular table. So suppose you wanted to do that in KQL, it's quite simple, right? So what you have to do is just type the table's name, and in the Azure Data Explorer, it basically pre-senses and IntelliSenses what you're typing, and it fills it out for you. So once you've written the table's name out and you just hit run, that's it. It's basically just going to query the whole table for you, and then it's going to list it out for you in a tabular form. And what's interesting about the Azure Data Explorer is, you'll see in a minute, it comes with all sorts of info about the table that's been queried, right? So you get your counts, and you can quickly make them into visuals or charts. You can quickly copy the output. A lot of the stuff which is not available to us in SSMS is now available to us here in the Azure Data Explorer. So yeah, you can see some stats about your table, execution time, and then it also shows you some counts, and you can order your data, and this basically, when you write the table name and hit run, it basically queries the full table, very similar to a select star from that we would commonly use in SQL. If you don't know much about SQL, I have a playlist. I'll link to that playlist, but it's not necessary that you do know it. Just understand that if you want to find all the information in the table, in a particular table, and list it out in a tabular format, just write the table's name and hit run. Alright, so now that we've got that out of the way, the second most important thing to remember about SQL queries is the pipe operator. Alright, so the pipe operator, if you don't know where that is or how it looks, it's basically like a straight line, similar to an eye but much longer. So where can you find it? If you're on a Mac, it's right under the delete key, next in a common button with the slash. So you have to use the shift and press that button, and you get the pipe operator. Similarly, in Windows, the pipe operator will be below the backspace, um, uh, along sharing a button with the slash, and again you have to use the shift to use that button. And why we use the pipe operator in KQL. It's quite interesting, right? So what it does is, because we're working with large amounts of data and it doesn't want to overburden whatever processing or compute you're using, the pipe operator sort of tells the compiler that, okay, whatever's before the pipe, only those results pass it on to the next stage, which is whatever operator comes after the pipe, right? So suppose we wanted to, it'll become a bit more clear to you as we go through the video, but what it basically does is it gives you sort of a sequential way to go through your query. So if you were an SQL, we could do a where on some condition, and then if we hit the pipe operator again, and then we did group by, what would happen is it would first query the whole table, and then when it hits that pipe operator, it passes all the data from that particular table to this next part of the query, and it filters on a particular condition where. So obviously the number of rows reduces, and this limited row group of rows which comes here, when it hits this pipe, the next pipe, only those particular rows are passed on to the next part of the statement. So when it does the group by, it is only working on the data which has already been filtered out in where, because it comes through the pipe, or it comes sequentially from a previous statement separated by a pipe. So this pipe logically separates the result, and it basically separates previous results and passes only the required ones on to the next part. So it's quite interesting. You'll get more clear with it once we go through the demonstration. But now an important function or operator that we use in KQL is the count operator. So it tells us how many rows a particular table has, and it's very simple to use. So if you want to use the count operator, just write the table name for which you want to find the row count, pipe, and in the next line, and just hit count. Once you hit count, it's going to run and it returns the number of rows that you have. Alright, so that's one operator done, right? That's the count operator. Similarly, we have another one which we call the take operator. The take operator, what it does is it basically allows us to select a subset of the data or see a sample set of the data. So normally these streaming data which would reside in your data explorer and which you would be using Kusto to query will have huge row counts, right? So if you just want to see what the structure of the table is, right, you just need to see a sample subset of this data. So that's why we use the take operator, and we can do take and then specify a number. All right, so we can do whatever number we want, and it's going to return only that many number of rows from the top of the table. All right, so this gives you a chance to see what the data looks like, and similarly what the structure, data types, and things are. So you can even do a take one, and you get just one row of data then, right? So the first row is probably a null row. So that's what's happened here. Yeah, so that's how the take operator works. It allows you to see a sample or a subset of the data that you're working with. All right. So next, what we would want to figure out is how we could only display, suppose your table is very large and had a lot of columns, how can we project only a subset of columns, right? And that's where the project operator comes in. All right, so we're going to use the project operator to project just a subset of the columns in the output. So we're going to here use multiple pipe operators, our first real statement with multiple pipe operators, and here you'll start to get an idea of how the pipe operator comes in handy, right? So what we've done is we've queried this table, and initially it's looking at this whole table with a lot of data, but with the pipe it goes in and realizes, okay, we just need the first 5 rows, and then only these first 5 rows are taken into the next part of this statement which comes after the pipe operator. So this could have been anything. This could have been compute intensive. Right now we're just projecting a few columns from those first 5 rows, but if it was compute intensive, we could see how much of a savings we could make if we do the take 5 previously before a pipe operator from the next operation. So we can do project, we can give some random columns, we can do a state, we can do an episode ID. The IntelliSense knows the columns as well, so it's really spoiling you here. And when we hit run, we should see data for these 3 columns, but only the first 5, right? So what's happened is, from the entire storm events table, it's taken the first 5 rows, and then when it hits the pipe operator, it passes only these first 5 rows with all columns into the next part, and then it realizes, okay, the next part is from these first 5 columns, first 5 rows, only project these 3 particular columns. So that's how the project statement works, and we also got a better idea of how the take statement works. All right. So the next operator that we're going to be looking at is the distinct operator. All right. So what that does is it basically allows us to um, look at the unique values in a particular column, right? So we're very used to this. If you know SQL, you know the select distinct. Similarly, it's the same operator in KQL. We just use distinct, and we specify the row that we want. So suppose I want to see the distinct or the unique states which have data within this particular table. I can just hit storm events pipe distinct state, and it gives you a list of all the distinct states available to us. So this again becomes a sort of table, and if we wanted, we know what the row count is, but if we wanted to get it as a number in the output, we would again hit the pipe, and then that table of 68 individual or unique states would be passed to this count operator, and this count would then obviously return to us the number of rows in that table, which is 68. So again, a better understanding of the pipe operator and how it works, and also you got an idea of how the distinct operator works here. So interesting. That's quite heavily used in the distinct in KQL. All right. So now, apart from distinct, suppose we wanted to do some little more tedious tasks, like we wanted to rename columns and things like that. So how would we do that, right? So I'm just going to do a take 5 to get an idea of what the table is and some of the columns that we can work with. So you can see we've got this event type column here, right? Suppose we wanted to rename this event type column as just event category or something like that, right? So what we would do is we would hit the pipe, and from these first 5 rows we would do event category equal to event type, and we have to put that in a project. All right. So now when we run this, we get event category, which is actually the event type table, but wrapped in the event category alias, right? So that's how you rename a particular column. And so if we wanted all the columns, we would just have to do an extend instead of a project, and then you would see that this event type column has been duplicated at the end with a new name called the event category column, right? So basically, let's just recap what I've done here. Initially, when I wanted to rename this event type column into event category, I just did a project, right? And what that's done is, when after this take 5 and when before going into the next operation, it hits the pipe, right? And at that stage, it has 5 rows with the original column names. But then it hits this project event category as event type equal to event type, and what that does is it looks for the event type column and renames that as event category, right? But we've only projected that one event category column from the old event type column name. So that's the only output that we get. We could comma and then specify as many other column names as we wanted, but right now that's not what's required. So we've just got the event category. But suppose we wanted to display all the existing column names and just add this one new column, event category, from or based on or renamed from the event type column, right? That's when we use this extend operator. And what that does is it sucks in all the previous columns that we had, and then removes and then adds this event category column based on the old event type column. So that's how we saw we had, oh, sorry, we don't need the comma there. And that's how you saw that we had the event ID, which was the event type, which was the original column, and then at the end we have an extended column which is event category, which is basically event type just renamed as event category and added or extended as a new column. So that's interesting. And another thing that we might want to do in this situation is remove a column, right? So since we've already renamed event type as event category and we've extended it at the end, suppose we want to remove it, what would we do? We would do project away. So that is project away, hyphened away, and then we can just specify event type so that we don't get both those columns with two different names in this final table, right? So you can see that we've lost that event type which was initially here, but at the end we still have our event category type. So that is how we remove columns using the project away operator. So again, that's quite an interesting operator to work with. Then we've looked at our distinct already. So now we come into some vital operators in KQL, and that is the where or filter operators. So it's quite similar to the where in SQL, where you can filter your particular output by some conditions and you can logically bind them together using the AND and OR operators. So we can do, suppose we do storm events and we want to filter the data from the state of Texas, right? So we just do where state equal to, and then strings you have to mention within double quotes. So we can do where state equal to Texas, right? And it's querying that data. So that looks quite interesting. And we have all sorts of data in here, right? A lot of droughts, strong wind, winter storm, ice storm. So then we can use our logical operators to further filter the storm criteria, right? I mean the storm events. Yeah, we could further or at a more granular level filter out our storm events table. So suppose we wanted where state was Texas and event type was winter storm, we could go in and do that. So if you guys are new to logical operators, I think definitely check them out. They're quite interesting, but also a vital part of any programming, be it Python, SQL, or any programming in general. It's an important knowledge to have. So check out some videos on that topic, and you'll quickly understand. So we basically just have the AND and the OR operator, and they can be used quite creatively. So if I hit an OR here, you'd notice that once OR has been used, I get states other than Texas. But where the state is not Texas, it will probably be an event type of winter storm, since one of the conditions has to be true. So that's how we use the where condition or the where operator in KQL to filter out data. Quite an important operator to work with in KQL, since we're working with huge sets of data coming from large systems, and we want to subsegment the data based on any large conditions. We always use the where operator. So a good important operator to know. Next, we can come to the sorting capabilities in KQL. So this is again a similar concept to what we have in SQL, where we can do a sort by based on a column and then return the data in an ascending or descending order. So basically what we're going to do is we're going to hit storm events, and then we can do maybe a take 10 just to make this easier to understand, right? Because otherwise there's just too much data to work with. And then we can see we have this damaged property index, right? So suppose we wanted to sort by damaged property, what could we do? We hit the pipe to further work on this particular result set, and then we can do sort by and then mention the column name. Again, If you know SQL, it's quite handy and intuitive to use KQL, since the principles are more or less the same. You've just got to learn the new syntax and operators. So we're going to sort by damage property, and by default, remember that KQL sorts in the descending order, right? So you can see we start from the largest number all the way down to 0. If you want to specify specifically that it should be ascending, we just hit ASC, and then that order should change for us, and we should start from 0 all the way down to 3000, which will be the largest value. We can explicitly mention DESC, but by default, this particular table, this particular KQL implementation sorts in the descending order, right? All right. So then the next column that we're going to or the next operator that we're going to be looking at is the top n operator, right? So the top n operator, what it does is it basically returns the first 10 rows sorted by a specific column. So interesting. So if you wanted to see how that works, you can just do a storm events, and we're just going to specify some similar conditions like we had done while explaining the where operator. So we're going to do where state is equal to Texas and event type equal to flood, right? So we should have some handy data here. All right, so now this is where the top n operator comes in, right? So suppose we had all this data here, and we're like, okay, there's a lot of data, but I'm very interested in what are the top 5 damages done, or the 5 largest amounts of damage done by this particular type of event and in this state. So we have Texas floods, and what are the most 5 damaging floods that we could have seen, right? So that's where we use the top n operator. So how I would write that is, I'll just do top, specify the number by the column that we want to filter, right? So it's going to go into the damage property column, find the 5 biggest damages and sort them in descending order and display only those 5 rows. So quite a handy operator to use. As you can see, when we go to the damage property, we see we have a flood in Texas that cost $5 million of damage in first position. So that gives you an idea of how the top n operator works. So again, just to recap, if you have a data set, a result set ready, and then you want to go into that result set and filter the top 5 or top n number of rows for a specific column, that's where you can use the top n operator. All right, so that was the top n operator. Now we can start looking at this is another interesting concept. We can start looking at some calculated columns, right? So suppose we have 2 pieces of information that can be used to create another piece of information, be it a first name and a last name, and you want to merge them and create a full name. That's something that's called that would become a calculated column. Similarly, in this situation, we have the start time and the end time of each of these calamities or storm events, and if we want to catch the duration, we just need to subtract the end time from the start time, right? So that is where something like a calculated column comes in. And similar to the renaming of columns, how it works is we do a project and then specify the new calculated column's name. I'm going to call it duration, and then I'm going to call duration is equal to end time minus start time, because that's what our duration of the storm event would be, right? And similar to when we rename the column, the new column name is equal to the old column or the calculation done on the old columns. When we were renaming, we just specified the old column that was to be renamed, but now since we're doing a calculation, we mention that calculation after the equals to sign. So now when we run this, we get this particular column of durations of these first 5 most damaging flood events in Texas. So suppose we want to see it with all the other rows of data, we can just go back to our handy extend that we looked at earlier, where it's going to pull in all the previous rows, all the original rows, and at the end add this extra duration column which we just calculated right now. So that's how this calculation of columns work. It has infinite use cases, so you've probably seen this if you worked with SQL. Most arithmetic can be handled for these calculated columns as long as the data types are matching. So keep that in mind and be creative and try exploring how some of these calculated columns can be created. Alright guys, so that's it for this video. Please make sure to subscribe and hit the bell icon, like this video, comment if you have any more questions or topics you want to see. But in the next few videos in this particular playlist, we're going to be going into some of the more complex concepts such as joins. We're going to be looking at continuously streaming data, creating visuals from the streaming data, string searching, regex in KQL and things like that. So definitely stay subscribed so that you don't miss any of those updates. And once again, thank you guys for watching. Don't forget to like, subscribe, share, comment, and hit the bell icon. And I'll see you guys in the next one.